All right, so today we're diving deep into transformers.
Specifically how they work.
Yeah, how they work and like how they even came to be.
Yeah.
So you sent me over this awesome blog post by Pramod,
Yes.
and he seems to like break down everything step by step
Mhm.
and even includes like code examples.
For the really dedicated out there.
Yeah, so if you want to become like, cracked engineers,
Yeah, cracked engineers ready to,
you can follow along
yeah.
with Pramod's post.
It's really a fantastic post.
Yeah, cool.
So Transformers, I mean, they really have been a game changer in so many different fields, like natural language processing,
Yeah.
computer vision, you name it.
Yeah.
What makes them so special, I think, is their ability to see connections
Okay.
in data over long, like, stretches, right?
Yep, right.
Something that a lot of previous models, struggled with.
So like remembering the beginning of a sentence even when it's super long?
Exactly.
Right. Wow.
Yeah, exactly.
It's really cool.
So, for example, Pramod uses this example of translating I like pizza from English to Hindi.
Okay, yeah, I saw that.
Yeah.
So like how does a transformer actually like go about doing that? Like how does it even...
So at the core of a transformer is something called the encoder-decoder structure.
Okay.
And it's a little bit...
What is that?
Yeah, so think of it like this. The encoder
Okay.
is like a translator, right?
Yeah.
Who's fluent in both English and this other hidden common language.
Okay.
That only the decoder understands.
Gotcha. So the decoder then uses that to create the Hindi translation.
Exactly.
In our pizza example.
Yeah.
But like how does it like master both languages in the first place?
That's where this idea of self-attention comes in.
Self-attention.
Yeah, so it's a big innovation.
Okay.
And essentially what it allows the transformer to do is to analyze
Okay.
the links between words in a sentence, right? So this gives it a much deeper grasp of context and meaning than previous models.
Okay, I have to admit, when I first saw like query, key, and value in Pramod's post,
Right?
I was a bit lost. I was like, what are these?
Yeah, no, for sure. They sound intimidating.
Yeah.
But let's try to break it down.
Okay.
Using Pramod's example, right? So Pramod loves pizza.
Right. Pramod loves pizza. Got it.
So think of the query as, a question that you have about the sentence.
Okay.
Right. So like, who loves pizza?
Okay. Okay.
Right.
So the key would be like Pramod then.
Exactly.
Okay.
So that's the part
Answer the question.
that helps you answer the question.
Got it.
And then the value would be the actual answer that you pull out.
Which is still Pramod in this case.
Which is Pramod in this case.
Okay, cool.
Right.
So essentially, self-attention is letting the model figure out which words in a sentence are like most relevant to each other.
Exactly.
Yeah.
And so to do this,
Yeah.
they represent these words as like vectors.
Mm-hmm.
And then they use some clever math
Yeah.
with matrix multiplication.
Yeah. I was looking at those visuals
Yeah.
Pramod has in there for the attention score calculation.
Yes.
And it's surprisingly like, easy to follow, even if you're not like a math whiz.
Yeah, for sure. Yeah.
And then it seems like there's another layer to this, which is like this multi-head attention.
Right. Exactly.
You know?
So essentially it's like looking at this sentence, Pramod loves pizza
Yeah.
from multiple different angles.
I see.
So you get a much more complete picture.
So it's not just like one question, you're asking it multiple different questions.
I think that's okay.
Yeah.
Cool.
And so the source material has this really interesting visualization
Cool.
for Apple, market, and cell phone.
Mhm.
And it's really fascinating to see how different attention heads highlight different aspects
Okay.
of the meaning depending on what's being asked.
Interesting. Okay.
Yeah.
So what if the model it couldn't figure out the order of words in a sentence?
Right. Like, would that be a problem?
Yes,
Okay,
absolutely.
Okay.
Right. So Pramod loves pizza and pizza loves Pramod
Yeah.
are two very different things.
Yeah. That's true.
Right. So that's where this idea of positional encoding comes in.
Positional encoding.
Yeah.
Okay.
So you're essentially giving each word a tag
Okay.
that tells the model
Okay.
where it is in the sentence.
So if the model didn't know the order of words, like, things would get pretty mixed up.
Exactly.
How does positional encoding work?
Right.
Is it as simple as just like numbering the words?
It would be nice if it was that simple,
Yeah.
but we need something a bit more robust,
Okay.
especially for longer sentences.
Okay.
Right.
Yeah.
So just simple numbering wouldn't really capture
Mhm.
the nuances of word order
Yeah.
effectively.
Okay, so what's the solution then?
So the solution is to use sinusoidal functions,
Sinusoidal.
sine and cosine waves.
Okay.
Yeah.
Interesting.
And Pramo dives into like why this works.
Mm-hmm.
And I think the proof that he provides is surprisingly clear.
Yeah, I had to slow down a bit to like get the whole like sine and cosine thing.
Yeah.
But it's the step-by-step like breakdown he gives.
Yeah.
Makes it much easier to grasp even if you're not like a trigonometry expert.
Exactly. And the key is that this allows the model to handle much longer sequences
Okay.
and work across like different dimensions, right?
Mm-hmm.
So it gives it the flexibility to deal with various types of language data.
Okay, cool.
Yeah.
So we've got our words encoded with meaning and position.
Mhm.
Where do we go from here?
So now we go back to the encoder.
Back to the encoder. Okay,
Yeah.
so the encoder is like this multi-layered processing plant or something.
Exactly. So think of it as like a multi-layered, processing plant, where
Okay.
each layer
Yeah,
is refining the understanding of the sentence.
gotcha.
And Pramod has this really nice diagram
Yeah.
that shows like how the data flows through this encoder.
Mhm. He mentions things like residual connections and layer normalization and the feed-forward network.
Mm-hmm.
Can you break those down a bit? I'm a little fuzzy on what those are.
Yeah, for sure. So
Yeah.
imagine the residual connections are like shortcuts
Okay.
that allow information to bypass certain layers,
Okay.
right?
Okay.
And this really helps prevent information loss
Got it.
and improves the encoder's overall performance.
So it's like creating alternate routes for the data to flow through,
Yeah, exactly.
making sure nothing gets lost along the way.
Yeah, exactly.
Okay, what about layer normalization?
So layer normalization is all about
Yeah.
keeping the data that's flowing
Okay.
through the encoder
Yeah.
within a manageable range,
Mhm.
right? So it's like making sure the volume doesn't get too loud or too quiet.
Okay.
And it really helps to stabilize the training process.
Makes sense.
Yeah.
What about the feed-forward network?
Right.
Pramod describes it as like adding non-linearity, but
What does that even mean in this context?
so think of it as
Yeah.
giving each word like a moment of thinking time.
Okay.
Right? After it's gone through this self-attention process,
Okay.
it really helps the model
Yeah.
to learn more like complex and subtle patterns in the language.
So it's like taking a step back after the conversation between words,
Exactly.
like reflecting a bit
Yeah.
to like extract deeper meaning.
Exactly. Yeah.
That's cool.
Yeah.
So how does the decoder fit into all this?
Right.
Does it work like similarly to the encoder?
It does, but it has its own unique twists,
Okay.
right? So the decoder has to generate the output sequence
Okay.
word by word,
Okay.
right? And since it can only see the words that have already been generated, it's kind of like writing a story
Yeah.
where you can only use the words that you've already put down on the page.
That's a great analogy.
Yeah.
So while it's building the translation,
It's also like paying attention to what the encoder learned about the original sentence.
exactly. Yeah.
Right.
And that's called cross attention.
Cranks attention.
Yeah.
Okay.
So it lets the decoder use that context learned by the encoder
Okay.
to generate a translation that actually makes sense
Gotcha.
and is relevant to the original input.
Wow, it's crazy how much is happening inside this black box. But it's all starting to click now.
Yeah.
So how do we go from all these calculations to like the actual Hindi translation?
Right.
Like what's the final step?
So the decoder's output is still just a bunch of numbers,
Okay.
right?
Yeah.
It needs to be transformed back into actual words.
Right. Oh,
So-
how does that happen?
The decoder's output goes into what's called the linear layer.
Okay.
And this layer scores each word in the vocabulary
Okay.
based on how relevant it is
Mm-hmm.
to the generated sequence.
Gotcha.
And then this is followed by a softmax layer that turns those scores into probabilities.
So it's like, okay, based on everything we've analyzed, this word has the highest chance of being the correct next word
Exactly.
in the Hindi translation.
Yeah.
Got it.
And then the word with the highest probability
Yeah.
becomes part of the output.
Okay, that makes sense.
Yeah,
It's so cool to see all these different components work together.
it is. Yeah.
And Pramod even provides like code examples,
Yeah.
which is like mind-blowing to me. It's a lot to take in, but
It is a lot, but seeing the code really makes it.
yeah, it makes it more tangible.
Yeah.
But remember, this is still a very simplified view.
Okay.
Modern transformers have a lot more going on,
Okay.
but these core concepts are really the foundation.
This has been so eye-opening, this
Yeah.
deep dive.
I'm glad.
And I love how, Pramod encourages, the readers to keep exploring
Yeah.
and keep asking questions.
Yeah.
Like curiosity is key.
Absolutely.
Yeah. And as we delve deeper into this world, it's important to remember that we've only just,
Scratch the surface.
scratched the surface.
Yeah.
There's so much more to discover
Totally.
and learn about how transformers are, shaping the future of language processing
Yeah.
and beyond.
Okay. I'm feeling inspired to learn more.
That's great.
We've definitely covered a ton of ground in this first part of our deep dive.
Yeah.
But before we get ahead of ourselves, I think let's pause here and we'll come back to explore another fascinating aspect of
Yeah.
Transformers in the next part.
Sounds good.
Okay?
Looking forward to it.
All right.
See you then.
See ya. You're right. There's still so much more to uncover about Transformers.
Yeah.
It's like we've just looked at the blueprint, and now it's time to see how this incredible machine
Yeah.
actually gets built and learns. Right.
Okay, so let's talk about training.
Yeah.
How does a transformer actually learn to do all this?
Pramod mentions this data set called Multi30K.
Yeah.
What is that about?
So Multi30K is a data set specifically designed for machine translation,
Okay.
which is the task that, the original Transformer paper was focused on.
Okay.
It has tons of sentences
Okay.
in multiple languages, right?
Mm-hmm.
So it makes it perfect for training a model
Okay.
to translate between them.
So instead of flashcards with single words,
Yeah.
we're showing the Transformer flashcards with whole sentences.
That's a great way to put it.
Okay, cool.
Yeah, so the model sees an English sentence
yeah.
paired with its Hindi translation.
Okay.
And then it tries to predict the Hindi translation just from the English input.
And I'm guessing it doesn't get it right every time.
Of course not, especially in the beginning.
Yeah, especially at the beginning.
Yeah.
So what happens when its translation is off?
So it receives feedback in the form of what's called a loss score.
A loss score.
Yeah, essentially telling it how far off its prediction was
Right, yeah.
from the correct translation.
So it's getting a grade on a test
Exactly, yeah.
and then seeing where it needs to improve.
Yeah.
Does it just keep trying the same sentence over and over again?
Not exactly.
Okay.
So this is where the magic of backpropagation comes in.
Back propagation.
Yeah, so using the loss score,
Okay.
the model tweaks its internal parameters.
Ah, okay.
Those weights and biases we talked about earlier?
Yeah, yeah.
The aim is to adjust these parameters
Okay.
to reduce the loss and hopefully make better predictions.
Okay.
Next time.
Pre-mode even includes code for a custom learning rate scheduler
Yeah.
called Transformer LR scheduler or something.
Transformer LR scheduler.
That sounds pretty complex.
It is, yeah.
So what are learning rate schedulers and why are they important?
So learning rate schedules are really crucial
Okay.
for optimizing the training process, right?
Mm-hmm.
They essentially control how much
Okay.
the model's parameters are adjusted
Okay.
with each update.
Got it.
So think of it like finding the right pace for learning,
Oh,
right?
yeah.
If you go too fast, you might miss important details.
Yeah.
But if you go too slow, it takes forever to get anywhere.
Right. So it's about finding that sweet spot.
Exactly.
So the model is learning steadily and efficiently.
Yeah.
So how does a scheduler figure out when to make big changes versus smaller adjustments?
So a good learning rate scheduler will dynamically adjust
Okay.
this step size throughout training, right?
Okay.
So it starts with bigger leaps early on
Okay.
and then gradually takes smaller steps as the model's predictions
Okay.
get closer and closer to the target.
Gotcha. Okay.
Yeah.
But this all sounds like it could take a lot of computing power.
Absolutely.
How do researchers actually manage this in practice?
Yeah, you're absolutely right. Training these models can be computationally very expensive. It often requires specialized hardware like GPUs or even TPUs.
Okay.
And the size of the data set also plays a role,
Okay.
right? The more examples the model sees,
Yeah.
the better it learns. But that also means more data to process.
Right. Okay.
Yeah.
Premod doesn't really go into detail about the hardware
Yeah.
or training time or anything.
Yeah.
But he does mention something called label smoothing.
Yes.
What is that all about?
So label smoothing is a technique that prevents the model
Okay.
from becoming overconfident in its predictions.
Okay.
So think of it like this. If the model sees the same sentence pair
Yeah.
over and over again, right?
Yeah.
it might start to just memorize the translation
Okay.
without really understanding the underlying structure of the language.
So it's like a student who, like, crams for a test
Exactly.
and then forgets everything after because they didn't actually learn the material.
Exactly. Yeah, great analogy.
Okay.
So label smoothing introduces a bit of like fuzziness into the training process,
Okay.
making it harder for the model to simply memorize the answers.
Gotcha.
And this really encourages the model to learn more generalizable patterns
Okay.
that will help it perform well
Okay.
on new unseen sentences.
It's a clever way to, like, make sure it's actually learning the language.
Yeah.
Instead of just
Yep.
memorizing specific examples.
Yeah.
I'm noticing that, like, Paramode provides code for a lot of these concepts.
He does, yeah.
Like the label smoothing, learning rate schedulers. It seems like he really wants people to, like, experiment with these ideas.
Absolutely. He's clearly very passionate about
Yeah.
making this technology accessible, right?
Yeah.
And giving people the tools to explore it firsthand.
Cool.
Yeah.
Speaking of experimentation, he also talks about using different optimizers during training.
Yes.
Can you remind me what an optimizer does?
Yeah. So think of an optimizer as a guide for the model.
Okay.
During training,
Okay.
it tells the model how to adjust its parameters
Okay.
based on that loss score.
Gotcha.
And there are many different types of optimizers,
Right.
each with its own strengths and weaknesses.
Mm-hmm.
So it's kind of like choosing the right coach for a sports team.
Okay.
You want someone whose expertise matches
Yeah.
the team's needs and goals.
So finding the right optimizer is part of the art of, like,
yeah, absolutely.
training the transformer.
It's not just about the data and the algorithms.
Yeah.
It's also about making, strategic choices that affect
Yeah.
how the model learns and performs.
Experimenting with different ones can, like, have a big impact
Yeah,
on
that's
the
right.
training process
Sure.
and the final, like, performance of the model.
Yeah, and it often takes a bit of trial and error
Okay.
to find the best fit
Gotcha.
for a specific task or data set.
So there's a lot more to training than just, like, feeding the model data.
Absolutely, yeah.
It's like understanding the different tools and techniques and then, like,
Making informed decisions.
making informed decisions about, like, how to use them effectively.
Yeah. Cool.
And Promote actually mentions that his, full notebook, including all the code,
Yeah,
is available on GitHub,
that's awesome.
which is a great resource for anyone who
Yeah.
wants to dive in and experiment themselves.
I totally agree.
Yeah.
Okay, so we've covered the encoder and decoder,
Yes.
self-attention, positional encoding, training data sets,
Yeah.
label smoothing,
Optimizers.
optimizers. It feels like we've explored
We've covered a lot.
every corner of the transformer world.
Yeah.
What else is there?
So we've mostly focused on the original transformer architecture.
Okay. Yeah.
But it's important to remember that this field is constantly evolving.
Okay.
There have been many variations and improvements
Okay.
since that first paper,
Okay.
leading to even more powerful and specialized models.
Ooh. Okay. Give me some examples. What are some of the big advancements that
Yeah.
have come after the original? Yeah. So one of the most prominent examples is BERT.
BERT. Yeah.
What is BERT? Bidirectional encoder representations from transformers.
That's a mouthful.
It is. Yeah.
Okay, so what makes BERT so special?
So BERT is it's a pre-trained
Yeah.
transformer model
Okay.
that's been trained on this massive data set of text and code.
Okay.
And this pre-training gives it a really deep understanding
Okay.
of language and context right out of the box,
Okay.
making it incredibly effective for a wide range of tasks,
Okay.
like question answering, summarizing text, analyzing sentiment, you name it.
So it's like a student who's already aced a bunch of classes before starting a new one.
Yeah,
So they have, like, a head start.
exactly.
They can learn new things faster.
And because BERT is pre-trained, right,
Yeah.
you don't need as much data or computing power
Okay.
to fine-tune it for a specific task,
Gotcha.
which has made it extremely popular
Okay.
in various fields.
It makes a lot of sense.
Yeah.
It feels like we've only just begun to explore
Yeah,
the possibilities
Okay.
of what Transformers can do.
for sure.
Is there anything else you wanted to share about BERT, or are there, like, other interesting developments
Yeah.
you think we should discuss?
Yeah, let's talk about some of the other
Oh.
cool stuff that's happening in the Transformer world.
Yeah, BERT definitely sounds like a major leap forward.
It is.
It's so cool to see how these models are evolving
Yeah.
and, like, becoming more powerful.
It really is. And BERT is just one example.
Yeah.
There's so many other exciting developments happening in the world of Transformers.
Yeah.
It feels like we're constantly, discovering
Yeah.
new ways to apply them
Yeah.
and like push the boundaries of what's possible with language processing.
It's crazy to think we've only just like scratched the surface.
I know, right? It's amazing.
So where do we go from here?
Right.
Like what's the next chapter in the Transformer story?
That's the million-dollar question, isn't it?
Yeah.
You know, predicting the future is always a challenge.
Yeah.
But I think we can probably expect to see continued growth
Okay.
and innovation in a few key areas.
Okay. Give me some expert predictions here.
Okay.
What kind of advancements are you most excited about?
Well, I think we'll see a push for even more efficient training methods
Okay.
and architectures, right?
Okay.
So remember how we talked about the computational cost
Yeah.
of training these massive models?
Yeah. It's here.
Researchers are constantly looking for ways
Okay.
to make that process faster
Yeah.
and less resource intensive.
It makes sense. Like making these powerful tools more accessible. This will be a huge win.
Yeah, absolutely.
It would allow like more researchers and developers to
Yeah.
contribute to the field.
For sure.
What else is on your radar?
So another area I'm particularly excited about is the development of even more specialized transformers.
Okay.
Right. So we've already seen models like BERT
Yeah.
that, excel at these specific tasks.
Mhm.
I think we're going to see even more models tailored
Okay.
for very, very specific applications.
Okay.
Right.
Oh.
From scientific research to creative writing
Wow.
and beyond.
So like we'll have transformers that are experts in different domains.
Exactly.
Able to do like
Yeah.
tasks that were previously like impossible
Yeah. It's like going from
or incredibly
the
difficult.
general purpose Swiss Army knife
Okay.
to like a whole set of specialized tools,
Yeah.
each perfectly suited for its job.
That opens up so many possibilities.
It does, yeah.
That's so cool.
And this specialization will allow us to,
yeah.
tackle even more like complex problems
Yeah.
and uncover new applications in fields we haven't even imagined yet.
It's a really exciting time
It is.
to be working with this technology.
Absolutely, yeah.
It sounds like the future of Transformers is bright
Yeah, I think so.
with advancements happening on multiple fronts.
Yeah.
It's amazing to think how far we've come in such a short time.
It is, yeah.
As we wrap up this deep dive,
Hmm.
I want to thank you for taking us on this
Oh, of course.
incredible journey into the world of Transformers.
It's been my pleasure.
It's been really fascinating.
I'm always happy to.
And a huge thank you to Premode for his
Yeah.
really insightful blog post, which
Sure.
made this whole exploration possible.
His blog post is fantastic, yeah.
And for our listeners, I hope you've enjoyed learning about Transformers
Yeah.
as much as we have. And if you're feeling inspired to dive deeper, remember that Premode's full notebook
Yes.
with all the code is available
On GitHub.
on his GitHub.
Yeah.
Keep exploring, keep learning,
Keep that curiosity alive.
and most importantly, keep
Yeah.
that curiosity alive.
Absolutely.
Until next time.
Sounds good. See ya.